homework solution 2.9. An AC load exhibits a lagging power factor of 0.73 at 230 volts AC and 315 amps. If the system frequency is 60 Hz, calculate reactive power, real power, apparent power, and the phase shift of the power triangle. So, or the power factor angle, I guess we call that mostly power factor angle. So given the power factor is equal to 0.73, given that the magnitude of the supply voltage is 230 volts, given that the magnitude of the supply current is 315 amps, F is equal to 60 Hertz. Find S, P, Q, and phi. So the magnitude of S is going to be equal to the magnitude of the current times the magnitude of the voltage, as we've seen in a couple previous examples. So that's 315 times 230. That gives me 72,450 volt amps. I know that the power factor can be defined as the ratio of P to S, and more specifically the magnitude of S. So P is equal to magnitude of S times the power factor. So that's 72,450 times 0.73. That gives me 52,888.5. And that's power, so it's measured in watts. And then Q is equal to the root of S squared minus P squared from Pythagorean's theorem. So you plug those in and you get 49,515.7 var. The power factor angle is just going to be the inverse cosine of the power factor, and that's going to be inverse cosine of 0.73, and that's 43.11 degrees. So if we were to combine all that into a power triangle, it would look like this. Don't think it asked for that, but it's always fun to do. 52,888.5 watts, 49,515.7 var, 72,450 volt amps, and a power factor angle of 43.11 degrees. This also illustrates another way to solve this problem. We could have solved for power factor angle first and said P is equal to magnitude of S cosine of the power factor angle, and Q is equal to magnitude of S times sine of the power factor angle. That would have given us the same answers there.